Enterprise teams are moving past simple chatbots. They're deploying autonomous AI agent swarms, interconnected networks of AI models that hold direct database access, developer credentials, and the ability to execute complex code on their own. But this autonomy introduces a unique vulnerability: prompt injections. Because agents process language as code, a malicious text prompt hidden inside a routine task can bypass standard firewalls, overriding system limits and rewriting the AI's internal logic. Once an agent is hijacked, the damage scales quickly. A compromised bot can query internal backups, escalate its own privileges, and exfiltrate database secrets through corporate Git repositories, all while appearing to perform its normal duties. Standard firewalls and endpoint monitors are designed to flag binary signatures and traffic spikes, but they lack the tools to interpret the intent behind an agent's internal reasoning loops. This interface is AgentTrust OS, a dedicated security command plane between the enterprise workspace and active AI swarms, evaluating autonomous operations. On boot, it maps dynamic topology on the radar grid, plants decoy honeypots, and primes instant network quarantine at the API gateway. To actually stop a prompt-driven breach, the security layer has to evaluate the context of the AI's behavior. It requires a system that speaks the language of the swarm directly at the operating system level. Let's look at the entry point. Accessing the swarm's control loop requires strict cryptographic authorization, routing operators through a clearance portal like this one, configured here for a Level 3 senior SOC analyst. Once inside, the platform renders this enterprise swarm map. It provides real-time observability into the hierarchy and trust posture of every active AI entity. For example, tracking high-risk entities like this finance copilot. Its node is green, indicating it is safely querying authorized databases. Without mapping this live telemetry and continuously verifying the trust posture of each node, securing an autonomous workforce is impossible. Watch what happens during a hijack. The finance copilot ingests a malicious prompt hidden in a routine spreadsheet. Instantly, its behavior breaks pattern, violently striking out toward restricted internal systems. The system doesn't wait to recognize a predefined malware signature. Instead, it looks at this behavioral DNA vector map. It detects a massive spike in execution velocity and a sharp deviation from the agent's baseline model shape. The finance copilot attempts to open salary_master.xlsx, a planted decoy file with zero business utility. This specific interaction triggers a high-confidence indicator of adversarial control. The moment that file is touched, the containment directive activates, automatically dropping the compromised agent into an isolated sandbox. This automated sequence traps the threat and halts data exfiltration in milliseconds, neutralizing the attack long before a human analyst ever sees the alert. Even outside of an active breach, autonomous agents require hard limits. If an agent requests a high-risk operation, like this bulk export of a salary database, the system suspends the action. It generates a pending approval card, halting execution until a human administrator reviews the rationale. These constraints are governed by the policy enforcement engine shown here. Rules like finance agent data boundaries are actively set to block, physically separating agent permissions and preventing unilateral data moves. Total unchecked autonomy is a security liability. Safely deploying AI requires rigid, unbreakable boundaries where human cryptographic authority always remains the final gatekeeper. Once contained, the postmortem begins. The threat center logs the Honeypot breach and confirms the agent's isolated status. Understanding the why is critical. The diagnostic engine translates telemetry, pinpointing exactly how the prompt injection hijacked the agent's reasoning. Quarantining the sandbox stops the immediate bleeding. Diagnosing the specific logic failure is what allows engineering teams to patch the prompt structure and harden policies against the next attack. To prove that these systems are secure, AgentTrust OS maintains this system audit trail. It functions as a tamper-proof ledger, recording every single autonomous operation and policy decision, secured by cryptographic SHA-256 hashes. This continuous, unalterable record maps directly to industry compliance standards. As seen on this dashboard, the audit trail automatically validates against frameworks like SOC 2 Type 2, generating the exact evidence required for global privacy regulations. The ultimate value of this platform is control. It allows enterprises to deploy massive, highly capable AI swarms internally without ever sacrificing corporate data sovereignty. AgentTrust OS provides a measurable, hardened perimeter for an unpredictable fleet. It ensures that as agents scale, the enterprise maintains a verifiable state of security.